Hey people, welcome back to the channel. Been a long time I couldn't make a video in English. Till the last video, we have seen about the evolution of the petrol fuel systems. So today we will see the evolution of diesel fuel system. So we are going to learn about indirect injection system, which is not existing anymore. Then we have the direct injection system. Then we get the turbocharged direct injection system. Then we will learn about the electronic fuel injection system. That is the common rail direct injection system in diesel. So we're going to see all this type of technologies, what we used to do in diesel engines. And this is the indirect injection system. So in the system, the diesel is sprayed into a small chamber, that is the pre-chamber, which is just above the combustion chamber. It's a small opening to the cylinder, so that the fuel is burnt here, and then the energy is transmitted from the pre-chamber to the combustion chamber, then to the piston, so that the piston is being pushed down, so that the engine works. So actually, this slows down the burning of the fuel. So the advantage of this technology is lesser noise levels, and the disadvantages were the lesser power, lesser torque, fuel efficiency were lesser, and more emissions. So this was ruled out. So later what we did is we put this injector directly to the cylinder. This is a direct injection system. So in this system, diesel is injected directly inside the cylinder, so just above the piston, so that the energy is being transmitted directly to the piston, so that the engine keeps working. And the advantages of this technology is more better power, more better torque, and more better fuel efficiency, and lesser emissions when compared to the IDI. But here what happens, the noise levels are more. So the IDI, the noise levels were lesser. So in this one, the noise levels are more. So let me see the fab table of this. That is a feature, advantage, and benefit. So here is the feature, advantage, and benefit of the differences between the indirect injection and the direct injection. So that's the thing. That's the same thing what I was telling you. The sound levels were lesser in indirect injection, but more in direct injection. So that's the advantage here, and that's the disadvantage here. But rest all, it feels advantages in the direct injection. How? When we take it to the indirect injection, so fuel efficiency, power, and the torque were lesser. So that's the disadvantages, and the emissions were more. That is also very big disadvantage. So direct injection, what happened? Much more improved. So here the fuel efficiency is much more better. The power and the torque is more. The emissions were lesser, so that we are saving on the environment. So what happened later? For the direct injection system, same, we fitted a turbocharger which gives you more denser air to the same the volume. But in this one, imagine I have given the intercooler here. Imagine there is no intercooler. So they used to come only with the turbocharger before. So that used to give more air to the same volume, so that it gives you more better power, more torque, and fuel efficiency was much more better. Emission levels were slightly lesser than the DI, but it has to be still more improved. But the noise levels still remain the same. Then later what happened? We fitted a intercooler. So that is a turbocharged intercooled direct injection system. We used to call as TDI. So that is the air entering the cylinder forced by the turbocharger, and then the diesel is injected directly inside the cylinder just above the piston. So that is same as your direct injection. But here what happened? The fresh air which is has to be burned inside the combustion chamber was more pressurized, and once we pressurize this, the air actually the temperature rises up. So what happened here is we have the intercooler, right? So intercooler will reduce the temperature of that air, making the oxygen more denser, so that burning is much more efficient inside the combustion chamber, so that it gives you more torque, more fuel efficiency, and the emissions were much more cleaner, but the noise levels were remaining the same because it's still in the direct injection. There's a mechanically controlled fuel injection system. So later what happened? To get much more better performances, lesser emissions, lesser noise levels, we need to upgrade to a electronical system. So that what happened later we will see here. So there are two. So in the diesel fuel system, there are two. So one is a mechanically controlled fuel injection system. Then another one is the electronically controlled one. So let's see what's inside. So this is the mechanical injection system. We used to use this in IDI. There's an indirect injection system and the DI. Both remain the same. Only thing is that the placement of the injector in the IDI was in a small chamber, and in the DI it is directly to the combustion chamber. So that's there in the pre-chamber, here in the combustion chamber. So that is the only difference. Rest all remains the same. It takes the fuel from the tank, filter it. This high pressure fuel pump used to give much more higher pressure of the diesel to the injectors. So whenever the injectors has to be opened, right? So it will open one shot, it give you more spray and then cut off. It's like that. Fuel pump function will be pressure increase and distribution type. So this will increase the pressure and distribute it to the injectors according to the firing order of the engine. Here what happened, at one shot we are burning it, right? So it's something like I'm talking about the crackers, playful Diwali crackers. So we have this autumn bomb, right? The bigger one, that tied one. When we burn this actually gives you one big blast sound, and this noise vibration is more, so much more than the smaller ones. When we used to play in our childhood days, right? What we used to do, we used to take the bomb, we used to untie it and take out this gunpowder, make it into small crackers. So we used to do that. So same thing we are doing it here, because again, when we are bursting bigger crackers, gives you more noise pollution and air pollution also. So what we want to do it now is make it to smaller crackers. But when you are bursting a bigger crackers, will be much more enjoyable for us. When we remove this gunpowder, it gives you a lesser noise, but we are burning the complete gunpowder. So like that. Instead of burning it at once, we want to burn it in stage wise, like 2 to 3 times, 4 times or 5 times, like that. So that's the reason we got into electronic fuel injection system. So this is the electronic fuel injection system, or the CRDi, the common rail direct injection system. How it works here? The diesel is taken from the tank, filtered it, then go to the high pressure fuel pump. So this is actually the same high pressure fuel pump, but here is not a distribution type. It is actually pressure increase, and which is increase up to 1400 bars. Imagine in your car tire or the motorcycle tire, you fill the air, right? It's around 2 to 2.2 bars, but here it is up to 1400 bars. Imagine the pressure what is built inside the common rail system. So from this 1400 bars of the pressure, the injectors are now electronically controlled, which is the ECM, that is the engine control module or electronic control unit. Both remain the same, but engine control module controls only the engine. So here what happens, the injectors are solenoid based. So according to the firing order, whichever the cylinder requires the fuel, it is sprayed accordingly inside the combustion chamber. But here the ECM will control how much the injector has to open. So that's how it is decided by the ECM, and it is all pre-programmed. Next, we come to the feature advantage benefit table here, which shows for the common rail direct injection system. And in this one, features ECM control electronic injectors. Advantage is that precise control of air fuel ratio, and benefit is more better torque, more better power, and better fuel efficiency. Then comes the pilot injection in 2 steps instead of one. In fact, in the mechanically control, it will be having one spray, as I said, one huge blast. But here it has 2 to 5 steps. It depends on the brands or the type of the model of the engine, and it can spray up to 5 times also. And controlled explosion, that is burning of the fuel in 2 steps or more. So this gives you lesser NVH levels, that is less noise and less vibrations. Of course, when we have more vibration, the noise levels, the harshness are there. So that is the you feel that engine is more harsh or more rough. So that is how it is. Here we mentioned it as vibration and the noise. So those are lesser. So here high pressure injection up to 1400 bars. In this what happens? The fine atomization of the fuel, helping the fuel to burn completely. Fine atomization in the sense, it's something like your perfume. When you spray the perfume, you get the fine droplets, right? So that droplets can be, it will be a little more, but that is kind of like a direct injection. That is a mechanically controlled. But when it comes to the common rail or the electronically controlled, it will be like your DO spray. DO spray has a gas inside, so kind of that. So that in the diesel, the density is higher when compared to petrol. Petrol can be converted to a gaseous form, but diesel is not much, cannot be much, but it can be sprayed in a fine form. So you can it is visible. So that the burning happens completely and resulting in much more better power, the torque. When these two power and torque are better, so the fuel efficiency will be much better, and end of the day, the emissions will be much more cleaner. That's what is mentioned here. More power and torque, lesser emissions. So all the parameters have been covered here for the diesel engine technology.